In 2024, I built an epic M42, M44 Frankenstein 16 valve BMW engine, and it turned out to be amazing and made really, really good power. But this year, 25, we're taking it to the next level. In 2025, I intend to take it to the next level. We're going big with this sucker, and here's how. Alright guys, so as mentioned in the intro, this is the start of the new build for the M44/42 Frankenstein, and it's going to have more acronyms because I've combined components from different manufacturers to make this and to make what I think is going to be something really special. Now, considering what I've done here, I've still done it on a budget, believe it or not, and I haven't gone crazy. I will tell you what the last piece of the puzzle is if we decide to go down that route. I'm not sure how this is all going to pan out in terms of power to weight with the E36 chassis, but there's only one way to find out. So thank you everybody who watched that video, the M44 Frankenstein build from 2024. I really appreciate all the positive comments and the feedback. It was a great build. But ultimately it was limited with what it was. Now, that engine made around 200 horsepower at the coast. That is on the flywheel. That's about 156 kilowatts on the flywheel. At the coast here in Gauteng, it was very different. So I'm going to refer to coastal numbers for now. I'm not going to kind of try and convert it to numbers up here. What do I expect from this? Well, let me take you through what we are going to do and what I've done, and why did we go down that route, and where are we going to go. So firstly, to start off, if you remember from Kyalami, the BMW M Fest last year in 2024, I raced there with the Frankenstein, and it ran bearings through not only the mine shaft but a few different corners. Okay, got a failure. And that ultimately kick-started this project. The crank got damaged. Obviously it ran a bearing, so the crank got damaged and the conrod got damaged. So I thought, okay, well, I also noticed when I stripped the motor that the valves started touching the pistons. And the reason this happens is because the standard valve springs are not strong enough to cope with the RPM. And inherently, if you keep revving it up past 7,000 RPM, these engines were originally never designed to operate up top there. So you could go there once or twice here and there, but if you keep going there, what happens is the valve spring gets a bit soft, and at high RPM, high speed, the valve can't close fast enough for the piston that's coming up. Ultimately, so the cam lobe is already off the valve bucket or the hydraulic lifter, and then the valve is still coming up, the spring is pushing it up at a certain speed, but the piston essentially comes up just a bit quicker and starts to just touch the valve. Now obviously if it's super high RPM, you'd get a smash and then it's catastrophe, and luckily we did not have that. It ran bearings before it did that, because if it does that, it basically bends the valve in the combustion chamber, and then the piston just keeps smacking the valve and destroys the engine. So luckily we didn't have that, so I was able to retain the cylinder head and all the good work we did there, and as well as the block and a lot of the good stuff. So that is what led to one of the parts of the engine. The other one was the crank got damaged. So the the M44 crank. Now if you remember, that motor was M44 bottom end and M42 top end. So M42 cylinder head because of the valve buckets, M44 has the rockers. M42 you get away with a better camshaft, more aggressive, and you can go wilder on the cam basically without buying special fancy cams, which I don't even think that they make. I haven't even checked, to be honest. On the bottom end, the crank is limited stroke of I think 83 millimeters. So basically it is a 1900, and that limits your power output because nothing beats capacity. There's no replacement for displacement. And obviously you can argue, depends on the design of your engine. If you want to run super high RPM, you might not want a 2.7 liter because of the piston speeds, whatever, you know. So you need to design your engine according to your needs. Torque versus power versus all these good things. Now the car that I'm racing, this E36 in the class I'm racing, I'm going to be up against 2.5 liters and 3 liters, pretty much stock 3 liters, but they still make a lot more torque, and out of the box they make probably more power than this is going to make. So I needed as much torque as I could get, and that's why we eventually went for an E46 320D crankshaft. So that is the M47 crank, and that is an 88 millimeter crank, and that's 5 mils extra on the stroke, which already gives it a massive bump in displacement. And these cranks are forged cranks. It's super hard. I know this because I spent probably the better part of 5-6 hours polishing this crank. Next up was a set of con rods. Now the standard con rods, I haven't really read anything about these con rods that is wrong with these. They seem to be pretty good up to probably 8,000 RPM. Based on the research I've done, if you're boosting it, obviously it's all completely different. We're not turboing this thing, we are running normally aspirated, so these con rods were going to be fine. However, one of them was damaged. So I took the opportunity to A, future-proof the engine, and B, try and save a bit of weight everywhere. So with that in mind, I went for a set of FCP engineering con rods. Now, the beautiful thing about a fancy I-beam con rod is that they all exactly the same weight, and they come with ARP 2000 con rod bolts. Their dimensions, it's obviously a forged steel, and like I say, the dimensions are all exactly the same. It's not cast iron or cast steel, this is forged steel, and it is just much stronger. So this can handle up to 600 horsepower and I think 9,500 RPM. We're never going to go near that. So that is one of the upgrades I did on top of the M47 crank. Next up was a piston. Now I did a lot of research on what I'm going to do with the pistons. The pistons, I could have used the same pistons that I had. I was concerned a bit about those though, because with the rods and the crank we could turn this thing up to a higher RPM. So I started searching around. I looked at M50, M3, S52, sorry, S52, S50, S52 con rods and pistons. The problem with the piston was the gudgeon pin was smaller than the M42 gudgeon pin. So I looked and I looked and I looked, and I eventually got lucky. I got put onto one of the Honda guys, and they had a set of K24 Honda forged pistons. Now I was originally looking at the K24 standard piston, the cast piston that comes with the K24 because the gudgeon pin size looked correct, and the compression height, that's the height between the top of the piston and the gudgeon pin, looked perfect. So in other words, we'd be able to get good compression. I found a set of pistons, couldn't find rings. Eventually I got put onto one of the Honda guys, and he had a set of used Wiseco pistons. Now, it was an opportunity I just could not miss. So I bought them, and it was a massive, massive investment. And I got them for an amazing price. So these pistons were obviously built for a K24. The combustion chamber on the piston was our biggest challenge. They just sat way too high. So my machinist and one of my good friends, Robert Cantwell, he spent a lot of his life machining these pistons to fit inside the cylinder head, and he's done an amazing job. And we had to go through many iterations of clearancing to get these things to clear inside the cylinder head, and eventually we did. But I mean, if you look at this thing, they're just so beautiful. So we are going to use these stunning Wiseco forged pistons, and they've been matched up with the conrods to fit inside the cylinder head, and that kind of gives us our bottom end. But what that did do is it presented a challenge, because the bore on these bad boys, well, the bore, I think on the standard bore is 85. The standard bore is 85, and these are the machined pistons I used for the M44, M42 Frankenstein. These bad boys, 86.5. We bored it out to 86.5 millimeter bore. Now the original K24s I was looking at were 87 mil bore, and that would have been great, but these Wiseco pistons were just, you know, it's a Wiseco forged piston, you cannot turn it down. So 86.5 bore. So now with the 88 mil stroke and 86.5 bore, that takes this out to a 2069 or something. It's almost a 2.1 liter, so it's close as damn it to a 2.1 liter now, which is fantastic because it gives us a lot more torque. It would have been great if it was a 2.4, but beggars can't be choosers. So let's do a weight comparison on these components. So we'll start with the conrod. So the stock conrod is 550 grams, right? The FCP Engineering conrod, 548 grams. Okay, so we saved 2 grams there. Not that big a difference. Let's look at the piston, right? So the piston, these heavily modified M50 pistons, 329 grams, 328 grams. And the Wiseco piston, 293 grams. So the biggest difference between the two is the pistons. So that means, well, not sure what that means, a small gain in weight, but that's about it. That ultimately presented the next challenge, which I didn't pick up right until the end, unfortunately. The next challenge is that a head gasket, the maximum size I could get locally in terms of the bore was only 85 millimeters, which is a problem because you cannot have a gasket sticking into the combustion chamber, basically with the bore slightly bigger than the gasket, especially on the fiber gaskets, because they just, it will not work. The other challenge is that with the piston, we could not take any more off of this piston. This is as much as we could take because the sealing of the piston becomes really thin. So we limited on the piston in terms of machining. We could not machine any more off. And then with the head gasket, the stock thickness is about 1.7 compressed. So that gave us a compression ratio of 21:1, which was a problem. So it was around there, somewhere around there originally. And then we machined it more to get it down, but ultimately the compression was way too high. I think we finished on 17 after getting the piston to this state. But ultimately I still could not run the stock gasket because of the bore. So I've had to have a custom gasket made from a company in Cape Town. And unfortunately that takes time. And I picked it up very late, and So we are waiting for that gasket. So it is a 3 millimeter thick copper head gasket, and it has the correct bore for this engine. So that is what we're waiting on. That will take the compression to about 13.7 to 1 before it compresses. So the copper gaskets do compress somewhat. I don't know by how much, but obviously the more it compresses, the higher the compression will go up. So we're probably sitting on about 14 to 1 compression, which is fine. It's a good number. I'm happy with that. It could have been a bit higher, but yeah, unfortunately with that challenge, there's not much we can do. So that is what it is on the bottom end. So we have the BMW M47 diesel crank, that's a 88 mil, the Wiseco 86.5 mil pistons. We have the FCP engineering conrods, and obviously the block has been bored out to take it to allow for the piston. So that takes it to almost a 2.1 liter. So what did we do to the head? Well, so like I said, the biggest limiting factor on a stock cylinder head is the valve springs, and I could see that the valves were just touching the pistons. I got very lucky with that. Okay, you don't see it on here, but got very lucky with that there was no damage on the cylinder head and the pistons. So what I've done is, if you go back to the M44-42 build, I used the stock camshaft and we reground them to the most aggressive grind I could go with the stock cams and regrinds, and that took us to about a 280 degree cam with 10.8 lift. That was the maximum we could go. And the challenge you have with that is your shimming and your valve bucket. So basically the way you shim and you set up the valve buckets, that becomes your limiting factor on your maximum lift and duration. So we couldn't do much more on the cams. But what I did do is I got a set of Supertech valve springs with titanium retainers. Now these are rated to 9,000 RPM as well, and they rated to 11 mils lift, I think 11 mils, 11.5 coil bind, something like that. So these were also pretty penny, and I waited a long time for these, as well as the conrods. But that does not limit us anymore on the valve train. And again, my good friend Robert from RC Motorsport, he helped me out with setting the valve heights and just going through the head. Now we've also done some more work on the valve seats, a lot of really trick work that the rally cars do, and other trick work on the head. That I can't show you because there's a lot of IP in that. I opened up the ports a bit more, cleaned them up. The finish was a bit rough. I asked for a rough finish, but I just cleaned it up a bit more. And that ultimately should just give us a better flowing head, especially for the increased capacity. Now with these valve springs, what I'm going to do is I am going to change the cam timing a bit, and I'm going to rev this out to 8,000 RPM. I'm not really going to take it past that because I'm not comfortable with the solid lifter conversion we've done here. I think 8 will be the maximum, so the limitable will be set at 8, and you know, it'll be able to live up there, but I won't really take it much more past there. The important thing is that the dual valve springs on the valve train will be able to cope with that, and we shouldn't have any issues there. I am going to tackle the bottom end. We're going to start with the conrods, the pistons, and set the piston ring gap. So it's quite a tedious process, and you will see why it takes so long to build a really good engine. So if you're interested, join us. I'm just using a stock aftermarket piston off the shelf with a piston ring installed. So the compression height basically is the same on this piston as it is on the Honda piston, and the pistons we're going to use, so we're going to use this. So what we're going to do is we take our stock ring and we always install it top side up, obviously, and whichever way you choose to have the orientation, you do it repeatedly the same. So in this case, we're going to have the gap on the intake side, and then we are going to basically close the ring so that it sits inside the block like so. And then take our piston and we set the height like so that the height is even all around. And that ring gap is what we are going to set. Alright, so when measuring the ring gap, you use a feeler gauge. Now on the Wiseco card that comes with the piston rings, there's a whole bunch of information, and there is a little table that you use here. We're using late model stock, and we're going to use that formula to basically calculate our ring information. Also, here's some other information you can use relative to your rings. So make sure you use the right ring. When I measure the ring gap, I get to about 0.278. Now when you measure it, your feeler gauge should kind of stick in there like that. That's kind of what you're aiming for. It's a good indication of what your gap is. So that is about 0.278. Now using that formula, we're looking for about 0.4. So I've already selected the 0.4 ring feeler gauge, and you can see it does not go into that gap. So we have to open that gap up. So let the gap opening begin. Take the ring out nice and gently. Make sure you don't damage the ring, and we can start. Now at top tier or really professional racing engine building outfits, they've got special ring grinders. I did see them on Temu. I couldn't get one in time, so I'm going to do it the old school way, and we're going to use a file. Now if there's a lot of material you need to take off, you can use a grinding wheel with a very soft stone and just gradually take off a little bit, measure, take off a little bit. The whole purpose is to just take minimal amounts off as possible each time and go through many iterations, rather than taking a chunk off and then you take too much off. Also to note, if you're taking material off with the grinding wheel, a machine, a specific ring grinding machine, it's important to not let the ring material get red hot, because that changes obviously the composition of the material and could make it brittle in the end, and then it might break off under running conditions. So there's a lot to take into account here. If you watch people using that ring grinding machine, the stone goes, or the cutter goes very slow, and that's what we're going to do here. We want to reduce excessive heat into the piston ring, and we just want to take off material. Another thing to note is that when you do it, you must make sure that the end gap, when it comes together, the line, it comes together straight. You don't have a gap like that or like that, and that because that'll obviously allow gases to pass through and you'll get blow by. So this is quite a critical step in the process, and this could mean the 1 or 2 kilowatts horsepower that you have right at the end. So make sure that your ring gaps are correct. We're going to do it slowly using the old method. If you want to see some more of this kind of content, please consider subscribing. Just click on the subscribe button, hit the bell, and you're good to go. Okay, now I am going to choose a side. Now I've got a piece of wood on my steel table here, and the objective is we are going to choose a side, put it on a sharp corner, and basically start cutting or relieving material. So whichever way you do it, you must be consistent. So if you do it on this side, make sure you do it on this side consistently, not this side, that side, this side, that side. And you want to try and get as straight a cut as possible. So you just take the file, put the ring as close to the gap, to the edge as possible, and try and file down. It's quite difficult because this ring material is super hard. Try not to get burrs on it. Also, just take your time, be very careful. We check, hold it up to the light, check that the gap is still straight. It looks straight, good. Now if you complain about the fact that your engine builder is charging you too much money, just remember what it takes. All the systematic steps, all the checks, all of the measurements, all of the cleaning, the whole process. It is an extensive process. That's looking good. The next step, just deburr the edge. Make sure there's no burrs on the edge that can mess up the bore. Feel it with your hand. So I've only taken off a little bit, and now we're going to check it in the block again. Right, put it back in the block, same orientation. Use the piston. Make sure it's right. Get your feeler gauge, 0.4. Oh, it's close. That's very close. It's going in a little. That's why this process is so critical. So 0.4, you can actually see it goes in a little bit. It's a bit too tight. See? So that we can take off a little bit more. Then take off the burrs. 0.4 millimeters. No, it doesn't feel like it wants to go in. 0.2, 78 goes in just fine. 0.4, okay, it doesn't go in. So we just keep at it. The Makita piston ring grinder 3000. This can be used anywhere, any place, but you need to exercise extreme caution when doing this. So what have I done? Well, I've taken my cordless drill, strapped it to the table with the cable tie, and we are basically going to use it to grind the piston ring. I've now cable tied the trigger down to a good speed, so the battery, I'll just slide it back in, and there we go. So now we're going to keep on going on the side that we were cutting on. Take off little bits at a time. So that is actually a bit too slow. Let's ramp it up a bit. Make sure, check that you're always cutting straight. Okay, so that's about as far as I'm willing to go right now. Check that it's straight. Ah, I've got it a bit skew. So now I have to go back, straighten it. Softly with a file, really fine file. Make sure you can feel there's no burrs. Try again. Alright, same procedure, put it back in, same orientation. Now it's important to note this block is already prepared, so it's bored and honed, ready for installation. Now you're supposed to actually use a torque plate when doing this. I don't have a torque plate, so we're still off. 0.2 goes in real easy. So yeah, still quite a lot to take off. I suspect the first time it went in, the ring was skew. So that is a good reason to check and check and check. Make sure the ring is always straight. Still lots to go. Alright, so we are finally there. So 0.4, it now goes into the gap nicely. Bit of resistance, and it's nice and snug. So that took a lot of iterations, probably 10 iterations, just taking your time. Eventually I used the bench grinder because it's the same kind of speed as the piston ring grinding tool. Now we're going to do the second ring. So we'll put this one aside, put it back in its #1 bag to make sure that it is always kept in its place. Now the second ring on these Wiseco piston rings have a little ridge on the outside of the ring. They call that a scraper ring. So we will use this obviously as the scraper ring. We're going to put it in, make sure you don't get any glove or anything caught in there. And then we move our piston ring down to the second ring on this. We push this piston down to its second position, obviously the second ring. So from here I just continued with the rest of the rings, doing the second rings first. The second rings turned out to be a lot softer than the top ring, and ended up messing up 2 of them. Luckily I had spares, so I was able to just kind of dig into the stash and sort the rings out with the file, and then moved on to the top rings to get the gaps all perfect. This is a super tedious process, and it just takes a super long time, and just take your time with it. Alright, so we managed to get all 4 of them done. I've now kept them packaged nicely, 1, 2, 3, 4. Admittedly, I messed up 2 of the rings, and luckily I had spares, and that's how sensitive this process is. And yeah, unfortunately I just went too large on the gap, trying to get too greedy, and yeah, messed it up. So luckily I had spares. It's not always the case that you have spares. So I'm going to put this aside because I am actually waiting for the crankshaft. And then a storm rolled in and interrupted my audio, so it took a while for me to get things back on track, but yeah, then I just kind of settled into cleaning up the ITBs. Alright, so it is bucketing down. I'm sure you can hear in the background. What I want to do, the last thing I want to do is I want to just mark the pistons 1, 2, 3, 4 so that we are consistent. So this new piston, I'm going to make that number 1 because that was measured on the compression ratio, so I'm just going to use my grinding tool. Now I'm just going to put the piston rings here by the pistons because I am still going to clean these before I put them in. I'll clean the ring grooves, and I'm going to keep this free of dust. So just cover it up and put it in a safe place. So I have stripped each one of the throttle bodies. I'm pretty much going to give them a clean each. I was going to try and have this stuff zinc coated, but you can't get the bush out of this, so I'm going to get some silver paint and just paint over it where the blasting has taken the plating off so that it doesn't rust. This manifold I'll just clean up, and then I can reassemble all of these bits. There is one last piece we're going to go over today, and then we're going to call it for this video. Alright, so the thing we have been so eagerly anticipating has finally arrived, and it arrived all the way from Cape Town. So some say that it is pretty hit and miss with this process. I've heard good things, and I've seen people run it with no challenges, and that is a copper head gasket. Now for our compression ratio, we've had to go for a 3mm thick copper head gasket, which is pretty wild. So there it is. Let's just get the orientation correct. Yeah, and I'm going to show you how it fits up in a sec. I have checked it against the stock fiber head gasket, and it does line up. So like I say, people have had very hit and miss results with this, and that's because often they supply the incorrect sump, so or there's a mix up with the type of, so often they mix up the gaskets and whatever. So it's important to actually supply a sample with what you are doing, so to your supplier. But anyway, we managed to get the right head gasket. It aligns very nicely here, and if I overlay it with the stock gasket, we pretty much get the same result. So I'm pretty happy with what we have here. Let me show you what it looks like.
You can see the riding on the pavement. Young kids, they're growing up in basements. Online, a whole new generation. I'ma make mine, so you better go take it. Always they need a new replacement. Decent
Alright, so it is also a couple of days later and I'm pleased to announce I've got the crank back and I've got the sump back. So super stoked we can actually start building the engine now. So the crank is back, we've done all the machining on the front. It's got a double keyway, I'll show you that when we assemble it. Let's get on to the sump. So as I mentioned before, with the sump what we are going to do is we are going to just improve the sump because it was really good. But it did still surge, and we found out a couple of things in the process. So with the design I'm going to continue to run the windage plate because the windage tray does serve a purpose. That's really important. Next thing is I am going to continue to run this baffle because this baffle stops the oil from coming out. It actually does a really good job of that. I'll obviously still run this tube here because that runs into the suction section, so that's what we've done there. In terms of the inside, it looks pretty much the same. What we did do is we opened up this bottom ring and we just gave it a bit more grooves to allow the oil to return inside this ring when it is busy scavenging the oil. So in other words, that puppy sits like that and then it sucks the oil up through this ring. So we've opened it up around the bottom and we've just allowed oil to draw back into that area. And with this cap on, so with the cap on, you're going to have limited slosh coming out of there. Also, the key thing we have done, ta-da! Ooh. Ah. So the key upgrade to this whole sump was this extra little box that we've put on the side here. Now that adds 1 extra liter of oil. So now when you put the windage tray back on and you fill the sump with oil with its designated 5 liters of oil, remember the oil was going to sit further up higher. The oil was going to sit higher up. We could only get, I think, 3 or something liters in here. Now when you fill it up with a full 5 liters, all of the oil sits in the sump. So I'm super stoked about that, and that means that in cornering the oil level is not going to sit up here. It's not going to sit up here super high and then you corner and then the oil's already pulling itself out. The oil level is going to sit lower down and it's going to sit in this catchment area. So that means we've just changed where the oil lives and we've moved it to the bottom here. So I'm super stoked with that. So I must say thank you again to my friend Robert from RC Motorsport. Thank you for helping me with that. He's done an amazing job. It's always good with all of your components before you start your build. You need to clean everything and make sure it's clean. We're going to give it the full Monty. And I'm using the Ravenol brake cleaner, of course. Only the best. From there I went on to clean all the bearing caps and the bearing shells and install the bearing shells into the block and prep the crank so that we could start the process of checking the clearances with plastic gauge. Here I just installed the crank, make sure not to rotate the crank, and then I cleaned and installed each bearing cap into the pedestals for the main bearings. Then I cut the plastic gauges to the correct size and placed each plastic gauge on each main bearing. And then installed the bearing caps. And the clearances came out perfect, 0.038 millimeters. I then had fun trying to install the oil squirters, and this was a bit of a challenge for some reason. Then just used my trusty red line assembly lube and went through all of the bearings, obviously cleaning off the plastic gauge first and then making sure all the bearings were well lubed. I then moved on to the pedestal bearing caps and lubed them, making sure that there is a decent layer of assembly lube for startup. Well, it's really for cranking for oil pressure, because that can take a very long time sometimes. Oh man, there we go, getting it all together. We're going to use ARP lube on the mains. Like you saw in the first round, we need to put the cap on with the bolts so that we can make sure they align. Just to check that the bearing is in the correct orientation. Make sure the GoPros are running. So much to do. Number 2. Number 3. See, it has lube, assembly lube, ARP lube on the bolts, on the thread, and on the heads. Bearing is the correct way around. Bolts turn nicely. Lube, bolts, assembly lube, orientation. Alright, lube, bolt, bolt. Okay, we'll do the 20 newtons first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like 50 degrees. I think what we're gonna do, oh, that's why. 7, 8, 9. Oh yeah, that is amazing. Wow. Look at that. Beautiful. After a long and painful process, managed to get all of the big end clearances sorted. So super happy. They're all within spec. And that spec is 0.038 millimeters. So super happy with that. From here it is assembly time. So the crank is already in. Now we're just going to put the piston rings on and start assembling the final assembly. So super stoked with that. It's the end of a long day. I installed a lift over the last week and it's been killing me. So at least that's done. I can now start focusing on this stuff and get this thing done. So there's a lot of small things we got to do, but all good. So we'll see you in the next couple of days. If you want to see some more of this kind of content, please consider subscribing. Just click on the subscribe button, hit the bell, and you're good to go. Alright, so it is a new day here and we're going to start with the piston installation, piston conrod assembly installation. And there's a bit of things we got to do, but obviously it's the same simple process. So let me flip this around real quick. Okay, grab cylinder number 1. So I still have the bearings installed, which is fine. And what we need to do is we need to obviously wipe down the block, and then the rings. Remember, we marked all the rings 1, 2, 3, 4. So these rings obviously need to go with each piston on each specific cylinder. So let me wipe the block down real quick, just again to make sure it's clean. And then I had to change the orientation of the oil squirters to make sure that they're clear. So I need to just make sure that that is all good. Can't believe how well this crank turns. Still can't believe it. So this is the intake side. Make sure that the intake side of the piston is all lined up properly. We're going to start with this bottom oil ring. Always remember the orientation of the gaps. You always clock it either 90 or 180 with each ring specifically. So we're going to put a ring on the bottom. So the gap is here, so we're going to install the gap for the bottom oil ring 90 degrees away from it, so that is nice. And this one 90 degrees. Okay, so spring oil ring gap here, bottom oil ring, top oil ring. Then we get the oil scraper ring. Make sure the groove is always facing down, make sure the ring is cleaned. Now this gets, we're going to put this ring 90 degrees on the thrust side on the intake. These are always a bit of a challenge, but and they're super brittle, so just make sure you don't break them. Take your time. And then the top ring will be installed 90 degrees from that. And there we go, those are rings. So I'm just going to do all the rings for all the cylinders, and then we'll come back. Right, bearings are all lubed up. Rod bolts are all lubed up with ARP Ultra Torque lube. It's time to go in. Catching on the conrod, so I have to realign that. Alright, so it's time to assemble this pump. Given this thing a clean, given the pump a clean, I've also ground out some of the edges there to free up oil flow. You can see I've kind of smoothed it over. So let's assemble. Now I'm going to be extremely liberal with the oil. Put a cloth under here so we don't drip everywhere. Want this kind of chamber to fill up these chambers as well. Okay, so new external ring. One ring to rule them all. And then we take the new internal gear. Gonna give this puppy a bunch of oil. Add a bunch of oil. There's the marking. Marking must be up, obviously, because it must locate. There. There we go. Alrighty, so like I say, I want oodles of oil in there because I want it to be able to prime quite easily. Alrighty, so that's good. Just gonna block that hole for now. What we'll do is just close this up. Now this obviously only goes a certain way. Not that way, not that way. There it is. Okay, now we get the bolts for it. Alright, so it is time to put the front cover on, and I'm putting Rhinzo seal around the water pump area just because I don't want it to leak. So, specifically on the aluminium front cover section. This over, dowel pins line up, screw that one in there. Oil pump is on, beautiful. And now we just put the bolts in. Okay, on with the main sprocket. We are making good progress. So we're now putting the timing chains in. The timing guides. Chain guides? That's what it is, the chain guides. Timing guides. Well, I guess it is a timing guide. And we're going to need these obviously for when we do the cam timing. Hand torque. Click. So I think it's time to put the cylinder head on. I'm a bit nervous, but you know, we just got to go step by step. It's been a while since I assembled this motor, so I'm just trying to remember the sequence, but yeah, I think it's time. Let's go. Alright, so first things first, we want to clean the deck, in other words the block. So let me just get a rag, nice clean towel, microfiber towel. So we're just cleaning the block, the surface of the block. We need to make space for the cylinder head here, so we're going to need to clean that too. And we are going to take our Redline cylinder head gasket. Now I got this from a company in Cape Town called Redline gaskets. So I've inserted the dowels here. It's very important that the dowels are there. So the gasket goes on. Now the tolerances are super close on this thing. So here we go, it's located on the dowels. If I look at all the ports and everything looks right. Just make sure. I did check it, everything looks good, so not much left to do but to do it. And this is the thing with this head gasket, it's a super tight tolerance. It can only go on one way. So there we go. So I'm not going to use copper gasket sealer. It says you don't have to, you just install it like that and it's go time. So let me get the cylinder head. Alright, the time has come. Cylinder head is going on. Man, this is a heavy cylinder head. Whoop. Oh, shit balls. I need that gasket. Oh man, I forgot about that. New gasket. Right, let's get it. Okay, so we might have a new challenge. What I'm going to do, just to be safe, is I'm going to clean this surface where the water pump goes. Clean the surface here, and I'm actually going to put some gasket seal on here because we're running a different height here. In fact, I might just put gasket seal on this whole thing because, like I say, the heights are completely different, just in case. Normally I wouldn't do this, but it's just a safety precaution because of the... come on. Okay, that looks like it's alright. Now, to get it in the there we go. Fell straight in. Beautiful. Okay. Now, we will need to bolt it down. Alrighty. Let's keep going. So, we're just gonna tighten these bolts all down. Okay. Quick update, I've taken the cams out, lubed everything, torqued the cam caps down, intake and exhaust. I have cleaned up the intake and exhaust sprockets, so those are on. Put this chain guard on. So what we're going to do now is we're going to route the chain and get it ready so that we can start doing cam timing. Let's go. So that is that fastened, and I have the washer. I just painted the washer because I had to modify it to suit. And there straight away we can see it's off TDC. So let's just get our 22 mil socket. All right. All right, so what happened there was actually very interesting. The exhaust cam was just out of position a little bit. It was retarded, and it was touching the piston when I tried to turn it over. So now you can see here the piston goes through TDC quite easily. So now we set it. So now we can take that all off. Got to be super careful though. Shit, such a delicate process. Luckily this cover locks in with 2 dowels, so it will not move in terms of its position. 100% true TDC. All right. We're going to use the stock arrows just because this one must move one tooth. No. That's not great. We need it in the middle of the slot. Right, and here comes the chain tensioner. Okay, so now I know this is not a perfect degree wheel. Don't judge me. I'm having some made that I would like to sell, so I'm busy prototyping those, but for now this will have to do. So I'm just setting the TDC mark. I've got the dial gauge on TDC. That is money. Okay, now we'll go around and make sure yep, 100% TDC. Okay, perfect. Let me set up the gauge on the intake cam and then we'll take it from there. Alright, so intake cam we're going to set to 110 degrees after TDC lobe center. It's 110 degrees, and now we must set the cam. Alright, so as mentioned we're going for 110 on the intake, so there you can see it's set to 110, and now we're just going to confirm. We're going to confirm max lift on the intake cam. There we go. Okay, right, intake is done. Exhaust we're going to make 108 degrees before top dead center. 360 minus 108, 252. 252 degrees, and now we have to set the max lift. So that is maximum lift at 252 degrees before top dead center. There we go. TDC number 1 firing, cam timing done. What did we do on the nose of the 320 diesel M47 crank? Now the M44/M42 and M47 cranks are very similar. However, the front part of the crank, the nose, is slightly different. And there's a few mods you have to do to make the M47 crank work on this motor, and these are the questions that I've received. So I thought, let me just run through it and how I got around it. I read up on a few technical articles about this, and the way they did it was different to how I did it. So let me run you through how I did it. So what we are talking about is the nose of the crank, the snout, and that is essentially this bit. The chain sprocket fits on here, as well as the dynamic balancer that fits on here. Now there's a couple of differences between this crank and an M42 or M44 crank. The first thing is the snout of the diesel crank is 0.5 millimeters larger in diameter than the M44 and M42, which poses a significant challenge. You need to run both, or you need to use the timing chain sprocket and the dynamic balancer on that shaft. So both of these need to slide onto the crank. So you might say, okay, well that isn't such a big challenge, all you do is you machine down the crank. Well, you can do that, but because the crank is so hard, it needs to go to a special engineering machine shop where they either grind it down or they use a very fancy tool to cut it down, and that is quite expensive because the tool is super expensive. I didn't go that route. What I did is I went to a friend who helps me with a lot of engineering work, and we machined down each one of the sprockets. So we machined the diameter on the sprocket by 0.5 mil, and obviously still giving it a very tight close tolerance. You still push it on, but it's quite tight on there because you don't want the sprocket to move around like this at all. So I machined this down by 0.5 millimeters, and I machined the dynamic balancer pulley down by 0.5 millimeters. Now the other challenge that there is that the M42 crank has one woodruff key. In other words, one key that is on quite far to the front of the crank snout. Now that key locates in this sprocket and this balancer, and they both line up and the key covers both. But on the diesel crank, the key is in a different position. So if you try and just use the one key on both of these, the sprocket or the dynamic balancer ends up turning. I forget which one it is. So you have two options here. Now the technical detail I read about this was that they machined out a second woodruff key. Now again, that crank material is so hard that you would need a very fancy cutter to machine out that second woodruff key, and that means breaking the surface, that super hard surface on the snout of the crank. So what we did is we extended the keyway and made the key one long key instead of having two keys. So we machined down in the existing keyway and just extended it, and then we made up one long key that slotted into the crank, and that way it covers both of these simultaneously. So you don't have two keys, you only have one key, and that way you also don't need a super fancy cutter to cut a second woodruff key. It's also better to have a square elongated key so that you know exactly that they are both lined up, and it's less risk of losing a key if you pull it out. So that is challenge 2. The third challenge comes in the form of the bolts. So this is the M42/M44 crank front pulley bolt. It is an M16 by 1.5 and it is pretty long. But the diesel crank has an M18 thread on the inside of the crank that is larger, an M18 by 1.5. So you can't use the M44, M42 front pulley bolt. So then what do you do if you don't have the M47 crank front pulley bolt? I don't know how long that bolt is either. It needs to be quite long because you're applying an excessive amount of torque on it. So now I didn't have that front pulley bolt because these cranks are super hard to find. I found mine in a scrapyard. So I had to innovate, come up with a solution. Your other challenge is your locating washer. This is very important because this washer has a little step in it, and that step centralizes the bolt on this front pulley. So it's very important to have that because that also makes sure that the bolt, the end of the bolt, is not doing anything like this, and you get a nice flush straight push on the front pulley. So what I ended up doing, I was actually going to try and find a very, very high tensile bolt, a special order one at a special length, and my engineering friend, he builds a lot of these VW TSI engines, Golf 7 engines, so he managed to find me a VW front pulley bolt. Now this is also a little bit shorter than the original bolt, so if you look at the lengths, it is about 5 to 8 mils shorter. However, I have checked the penetration on the thread, and this is good enough. So that is your next challenge, is to find a bolt that is going to work. I checked the M42 bolt, the M42 or M50 bolt that's from the 6 cylinders, that is too short, so that will not work on this application. So you need to find yourself a front pulley bolt that is more or less 120 millimeters long, 120, or with the washer on, 105 millimeters long. That's what you need. M18 by 1.5, 120 mils long if you don't have the washer, or 115 mils with the washer. So those are the three key elements to the diesel crank upgrade. It is the diameter of the snout on the front pulley, it's the second keyway, and it is the front bolt that houses everything. And this week I'm focusing on getting the engine installed. It's a massive task. I spent a lot of yesterday just bolting everything together on the front end, the valve cover. I have to do obviously the throttle bodies. I need to make up a bracket for the crank angle sensor because the crank does not have the tooth wheel on anymore, so there is a ton of stuff to do. I'm going to make the bracket first, pretty much focus on getting the throttle bodies in, getting it together so it can go in the car. So it's a big push of the next couple of days. Alright, so the time has come to finally get this puppy into the engine bay. So there's a couple of small things that I need to do. I need to put on the engine mounts and take it off the engine stand, put it on the ground, put the flywheel on, and tighten the front pulley, so the flywheel clutch assembly. So I'm going to get busy with that, and then we've got to get it in the engine bay. guys, it is in. Man, this thing's been kicking my ass for the last 3-4 hours, but it's in, and now I can start all the other small bits of work. After that, I buttoned up all the loose ends, and then it was time to get this bad boy cranked for oil pressure and then started.
Well, congrats.
Thank you. It's working.
I found the issue. It was the dwell time. So I just remembered we were sitting here. As the battery's dying, the ECU compensates for that. And there's a compensation factor, and you can actually increase the spark and increase the injection time. It runs good.
Yeah, it runs well.
It runs very well.
Before I forget, I must say a massive mega thank you to Sven from Gibbet Motorsports. He helped me with the setup of the ECU and changing it and calibrating it. He also is, him and I work together on fittings. I resell some of his fittings, and we work together on a few things. So massive thank you to Sven. His details are in the bottom, a link to his website and his socials and all that stuff. Go and support him. Thank you again. It's couldn't have done it without all that help. So alright guys, so it is the next day here, and as you saw last night, we managed to get this bad boy running, but we have no oil pressure. Now, I've had this issue before with this specific engine, and I didn't run it for long. I saw the oil pressure was not there. We tried to get oil pressure by running it, and no, it didn't come. So eventually I bypassed the oil cooler completely. What we tried doing is, I'm sure you saw, we tried filling the pump and like getting oil into the galleries of the pump to try and generate a hydraulic, some sort of hydraulic full, but that didn't work either. So that's the number one priority right now. So what I'm going to do, I've got some, we even used a bunch of the Ravenol 1060. I've got a cheap oil in there, but so what I did is I got 10 liters of other cheap oil. What I'm going to do is just flood the engine and try get the oil level above the pump so that it pushes out whatever airlock there is. So we're going to try that, but otherwise it runs really well. We just got to get oil pressure. That is mission critical at the moment. So just get these plugs out. Yeah, super wet. Lots of fuel because it has lots of compression. All right, let's fill this puppy up. We're gonna put 10 liters in it. And the idea is, get the oil level above the pickup to try and push out any air. Okay, let's see quickly on the dipstick how far up it is. So it is up there on the dipstick. So if I put that next to the motor here, I think that second 5 liters is required. So let's just go. Unfortunately, this is the race car life. Sometimes you have to resort to extremes. And we are gonna put the rest of this Ravenol 1060 in, the good stuff, so it can have its best fighting chance. So it should have 15, about 17 liters of oil in. It's 3 times the amount. So yeah, the whole idea is so that we can push out the airlock in the scavenge line. Battery's charged. All right, let's go again. Alright, so I have a plan here. I've connected this oil pump, put it into the dipstick, and I'm gonna try and pump oil back down into the pump. I know we gravity fed it yesterday, but I want to try and do this so maybe it with a solid stream of oil it can push out the bubble. Let's see. You can see it sucking oil out of the scavenge, throwing it back into the engine. Okay, I think I know what we're gonna do. Okay, Craig. Come on, boyki. Nope. We've managed to put everything together, get it in the car, and even get it started after a lot of fiddling because we had to relocate the crank angle sensor to the front because of the crank. So all of that was good. The only problem is that oil pressure was super low. In the end, the oil pressure is 0.5 bar, and that is just ridiculously low. So after much investigation, I figured out that the oil pump gears I bought to install the new ones are actually M42 oil pump gears, and the housing I have on is an M44 housing, and the gears are slightly taller and they are bigger. So the M44 oil pump is the one you want, and obviously that's why I ran it. And yep, I didn't pick it up. I ordered the gears as M44, they came as M42. I didn't pick it up, and yeah, that's why. So at the moment, this is where we are. So I need to basically strip everything out and get the oil pump out so that I can exchange the pump gears. Now I've looked around to see if I could find a new housing, but you can't really buy those things aftermarket, and nobody sells them. Beamer World, Turner Motorsport, I've googled everywhere, it's all just used stuff. So the only other option is I've tried BMW, they need a VIN. I'm going to try find a part number so that I could put a new housing on. I've contacted some of the local BMW guys, some guys that have got touring car versions of these, the S42. They're going to have a look to see if they've got newer ones. Otherwise, I can get M44 gears. So we're just going to see. Otherwise, I'll just put new M44 gears in. I don't want to put the old gears in because I want a high oil pressure specifically for this motor. The good news is, yeah, it started really after we figured out what was going on with obviously the timing and getting the timing all set up, and we richened up the table a bit, the fueling. Then it starts really easily. It's actually really nice. So I'm super pumped. So we're not going to take all of the bolts out. We're going to kind of loosen them to let the front of the sump drop, so that it just drops off that front cover. So from here we're going to use trusty old T-bar. Alright, so I have the sump bolts loosened off. The sump has kind of pulled away from this cover, so I just need to take the rest of the bolts off. Here's one outside 13 bolt. That'll go in its bag with the rest. There's one more bolt, 13mm on the outside. Then I have a few more on the inside, and then it can come. Oh man. Now this might be a bit of a challenge because the cylinder head is still clamping it down. It's like we got a bit of play. Can't get the persuader in anyway. There we go. Come on, you can do it. Go. Okay. And there she's off. So there she is in all her glory. Now I have been able to source from BMO in Pretoria a brand new M44 oil pump, BMW, new old stock. So that is amazing. That is a genuine BMW oil pump gears. To get the housing, it's another challenge, but we're going to forget that for now. Let's open this thing up and see where we get to. You can actually see how it moves up and down. That's because it is the wrong width, dumbass. So, brand new M42 gears do not work in an M44. Let me show you why. This is because the gears are actually thinner. I'll show you a comparison side to side, but you can see the step there, and that step results in the gears having a bit of play when that cover is on. And so all that happens is the oil just seeps out and just never builds any pressure. Let's get the old ones out and the new ones in. Take these old ones out. They look fine, as they should. What we'll do is just put them away for a rainy day. And now if we measure this, we only got 0.19 bar of oil pressure in this thing. So let's measure it. 8.4 millimeters. So that's 8.4 millimeters thick. That's BMW M42 oil pump gears, 8.4 millimeters thick. Now if we take the new old stock kit, let's measure these. So let's just make sure that these actually need a bit of a clean. They've been sitting in storage for a while. So let me give these a clean. Again, we put lots of oil around here. Come on, this is the inner ring. Yes, that's looking better. Clean the outer ring using Ravenol brake clean. Now let's measure the width. So this width is exactly 10 millimeters. So the difference is 1.6 mils. So let's give it quite a lot of oil. And dots up, and there she blows. Same level, beautiful. That should give us Maningi oil pressure, means a lot. So let's put this cover back on, put some more. We're gonna go through that same process, just prime it from reverse. Just clean these bolts, put Loctite on them, install them. So just a little bit on the threads. I ordered new gloves and they came in as XL, double XL. They don't fit. Torquing wrench, 10 Newton meters. 4. All done. She's ready to go back in. So it's another day and I am now going to clean this silicone off here that I used, the Rhinzo seal, to seal the water jacket. And the reason I did that was because of this super thick head gasket I used. You can check that out why I used that in the last episode or the last few episodes, but yeah, so I need to clean off this Rhinzo seal, clean up this oil, and then we can put that front cover back on. So let's lower it a bit. Just use a blade here. Now I've covered up the oil pan here, so now sealant goes into the sump. That is all done. I'm going to carefully take off this rag to remove any remains. Now I can wipe it down. So get the trusty Ravenol brake cleaner. This stuff is absolutely amazing. If you're interested, I resell it. Send me a DM. I'll get this stuff shipped to you. It is cheaper. I resell this stuff cheaper than competitive brake cleaners. And it is really, really good stuff. Send me a DM locally in South Africa. Send me a DM if you are interested in some. I'll hook you up. Alrighty, look at that. Squeaky clean. Just get some more. Oh, they're making a lovely noise next door. In the last episode, I don't know if you heard how they were panel beating away. That's because I have a panel beater next door to me. I've actually made good friends with. And he's going to be doing quite a lot of painting for me, which is great. So yeah, but they were busy with quite a bit of work in the last episode nonetheless. Beautiful. All right, so we need to do the same with this front cover. So that means getting all this RTV off, or Rhinzo seal there. Let's give this thing a clean and get it ready for installation. So we are going to use a nice microfiber towel and we're going to clean it all around. I'm not too worried about these surfaces here by the oil pump. The gasket can deal with oil there. It's just around here where I want to apply the RTV. Just want to give it a good clean. There's no oil residue. And the RTV sticks. Put that one side. Now, here is the gasket. What I'll do is wipe this gasket down first so there's minimal oil on it. This is a steel gasket, so give it a good clean. Alright, so now clean the gasket. Get it free of oil and residue. These gaskets haven't even worked properly. They've been through heat cycles obviously, but not significantly. Just want to get this engine to a point where it's working consistently. It needs to. There we go. Show me the money! Show me the money! Show me the money! Look at that. Get you some of that. Like a glove. We'll get some new plastic and cover this bad boy up. Alright, so here are all the bits laid out. I have everything bagged and tagged. The housing is there. All the other bits are laid out. So I'm pretty much ready to start installing. I'm gonna get busy installing this stuff. I am just gonna put the camera on the side and do a bit of a B-roll so that I don't waste your time with all of the little niggly bits. So yeah, let's get going. This is a prototype degree wheel I've made and I'm just testing it out. If I'm happy with it, I'm going to have them anodized and put them up for sale. So let's see how this goes. So I need to now make sure that this thing is at TDC. Sheesh, that was quite a lot. We'll take these to 16 Newton meters. And that's intake done. Let's do the exhaust. We're definitely going to make some changes to this degree wheel. I have the degrees going the normal way around, but they actually need to go the other way. Price you pay for development. Okay, let's put this on the exhaust cam. Right, that is pretty much in the dwell. So there we go. 108. Beautiful. Let's torque it down. Right, so we turn it over. That should be TDC. Awesome. Alright, here we go, round 2. So I don't have the alternator back because I have sent that in for reconditioning. So we are going to go without alternator, without water system. I also want to replace 2 water pipes. So I'm going to get those in a couple of days. Just make sure no oil is coming out the bottom. Some plug is in, everything's in, you just never know. Pouring it all over the cams so they can get lubrication. So that is 5 liters. I'll just put a bit extra in just in case, and then we need to put the valve cover on. So we're getting there, getting close now. Fire this puppy up. That should be plenty. It's about 6 liters. Let me put the valve cover on and we'll catch you guys then. All right, moment of truth. A lot of stuff is not connected at the moment. We're just gonna crank for oil pressure, and that's why you've got your sights on the oil pressure gauge. Now I'm gonna crank it from inside. I'll have to just connect that, connect the battery. I'm gonna crank it inside. Alrighty, so the power's off. On the other side, we need to unplug the injectors. Something else we got to do. Let's just make sure we're all safe. We don't want to be pumping fuel into the combustion chambers if we're not burning it. Alright, so what we're going to do is just crank until we see that oil pressure light go off. Let's go. Come on, you can do it. We will see it there also, 10 bar. How's oil pressure 10 bar? Huh? What? Oh, it's because it's unplugged there. Oh, no, don't tell me. We're doing this again. Man, this car and oil pressure. Right, so that didn't move. So let's try the old pumping process. We are now going to try and suck oil out through the pump and back into the sump. Let's go. We'll swap these two around and we'll suck it up through the dipstick, back, push it back through the pump for a while and then reverse it. Come on, pumpy pump. So that's pretty much as far as it will go, probably because of a non-turn valve or something, which is fine. That's actually a good sign because we weren't getting that before. Come on, boyki. Yes. 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 Oh man. Yes. Oil pressure. Fantastic. Gonna record this on my camera as well. Gloves off. Gloves are off. It's go time. Oil pressure. Let's go see what it is. And let's start it easy. Oh yeah. Oh yeah. Yes, we did it. Okay, well let's take this thing off and then we put the sensor back. Alright, I've got the Bosch sensor in, so I'll be able to see what the Bosch sensor is saying on the dash here. So let's see what that says. Nice and cammy. And now I am going to start this bad boy with some water in it. So I have buttoned up the cooling system and we are going to work to get this thing on the dyno. So I'm doing all the prep work and we've got oil pressure, it's all circulating. Gonna do the water cooling system. I remade the tensioner setup, so I've moved the tensioner, moved one of the old idlers, and now it's a much more simple setup. So we should be good, and now I just need to add some water and get this bad boy started and circulating water. I also want to get a couple of heat cycles through it, and then make sure there's no leaks, and then drain the oil. There's a couple of things we need to check. Obviously, get the water flowing through the system, but I also need to check for oil leaks. There was one on that side, and there's a water leak. Oh, come on! You gotta be shitting me. Oh, it's from the water pump. Remove the water pump. Now we have a water leak coming down from there, so it is the water pump. I did battle with it a bit, so let's go. So the O-ring pulled skew on the water pump. Fantastic. So I'm gonna see if I can find another one, and we'll put it back in. New O-ring in my O-ring stash. Fits just fine. Let's try again. Oh. Okay. Water pump is in, belt is on. Oh, come on. No. So it's leaking up in there, and that is because we have such a thick head gasket on there. The rubber seal in there is battling to seal. Shizer. Well guys, some sort of, all I can say is miracle happened. I had Caden, the other panel beater from next door, and we were looking at this thing, scratching our heads, and in frustration I just wanted to see how well the belt pulley ran and all that. And yeah, so I started it and ran it, and we put more and more water in just to confirm the leak, and all of a sudden the leak stopped. So what I think is, as it got hotter, the gasket must have just popped into place or something, and yeah, no more leaks. So I've run it hot and topped up the water, so yeah, no more leaks. So I'll start it again now, but it's amazing. I am gonna take that as a win. There's no more leaks, so fantastic. No leaks. Let's get it down and we'll start it. Alright, so the oil is super hot. I do that because then it can all drain out, but the risk factor is enormous. So that is the run in oil, looking fine. Alright guys, today is dyno day, and as you can see it is winter here in South Africa now, so I've dressed up warmly in the unit, but we're going to go through this puppy, and I've got to finish a couple of things for the dyno today. Now unfortunately, because of logistics, I'm not going to be able to be there to film it all, so I'm going to ask the guy to just take a couple of videos with the camera, and yeah, we'll just see what the outcome is. But what I want to do is go over this car quickly and just make sure that everything is still good. Now on the face of it, there's no water lying on the ground, so that's a massive win already, and it doesn't look like there's any oil, so let's just get a light. Everything looks okay. So what I must do now is change this oil filter, reroute the lines so that we plumb in the oil cooler, and then put the Ravenol race oil in, and we're good to go. Well guys, unfortunately I had issues with the microphone as well as some heavy background noise. Basically, we're going to be using the Ravenol RSS SAE 10W60. This is a polyalpha olefin based full synthetic multigrade engine oil with USVO technology. And what that means is that this is a full racing oil. So basically it's an extremely good oil designed for extreme stresses. I've worked together with Ravenol. They are a sponsor and they're going to be helping me this year, and we will be using this race oil throughout the year. So I'm very happy. The characteristics of this oil is it has safe lubricating layer at very high operating temperatures. It has high HTHS value, extreme shear stability, very stable and excellent viscosity behavior, very low evaporation tendency, very good cold start characteristics, very good detergent and dispersant characteristics, protection against corrosion and foam formation. Really happy to be working with Ravenol. Once again, thank you guys so much. If you want to see some more of this kind of content, please consider subscribing. Just click on the subscribe button, hit the bell, and you're good to go. Alright guys, so the dyno is done and it was really successful. We had quite a few small teething issues in the beginning, but Bram from Miller Performance or Miller Developments managed to sort it all out, so a massive thank you to Bram. He also took me through what he did and all of that, so really cool. We've set up protection in the ECU now. So the results of the dyno are this. So what you are looking at here are the two dyno graphs for this engine. One on the left is July 2024, and that was when the engine was in its first state of existence. The one on the right is the latest dyno, the dyno that we just did, with the high compression forged pistons, the H-beam rods, and all the other upgrades that we did. Just to note, we didn't change the camshafts. So on the left, you can see that now something to note is that this is at 1500 meters above sea level in Gauteng, in Johannesburg, South Africa, and this is on the wheels. This is also on a dyno that is quite conservative. So dyno numbers are only relative when you're doing back-to-back comparisons. So it makes no sense to try compare power numbers to other dynos because it will never be the same. There will always be differences. However, the important thing to note is that you use the same dyno and the same tuner to compare results, and that's exactly what we've done here. So on the left, last year July, when we first dynoed the car, it made on this dyno at sea level 100 kilowatts on the wheels. So to put that into perspective, an E30 2.7 Alpina makes 89 kilowatts on the wheels, and that is known as the 325S E30 Shadowline 2.7 here in South Africa, and that makes 89 kilowatts on the wheels on this dyno. So a 318IS E36 would probably only make something like 65, maybe 70 kilowatts on this dyno, conservatively. So 100 kilowatts is a good improvement over stock. And then it made 100, so that was at 6,900 RPM and 151 Newton meters at 5,800 or something like that. So that translated to 152 kilowatts on the flywheel when I dynoed it in Cape Town. And just keep that number in mind, because we're going to come back to that. And now when I dynoed it with all the upgrades we did, and I'm also running a 50-50 mix and of fuel, so 50% ethanol and 50% 95 pump fuel that we get locally. And the reason for that is just the compression. The compression's up at 14.4 or something to 1. So overall, with all of the changes we made, just keep in mind we used the Wiseco Honda forged pistons, which are heavily machined to fit into this engine. It's a larger, it's 86.5 millimeter bore. It now has the diesel crank, the M47 crank. It's pretty much a 2.1 liter. It has the 14.4 compression ratio, and and we did some upgrades on the head just to improve the flow, the H-beam rods, and yeah, I think that's pretty much it. So we're now seeing a power number of 111.2 at 7,600, and the torque is 153 Newton meters at 6,000. So I would have liked to have overlaid the graphs, but we weren't able to do that. So so what that means is we've picked up about 11.2% overall on the power, which doesn't sound like much, but I can tell you that the car is significantly different in its behavior, and you can see also the curve is a lot more linear. We don't have that massive spike that we used to have from 4,000 to 4.5. There is still a spike there, but it's not as aggressive, and that's that torque that is working so much better. And yeah, the power just keeps climbing. So I set the cam timing on the intake cam quite aggressive, to 110 degrees full lift, and you can see it. The car makes power much higher up, and it's okay to rev to 8,000 RPM. So I'm very happy with these results. On the right of the right, you will see a different set of results, and that's the dashed line, and that is when we pull the timing back a bit just to be a bit conservative and not push the engine so hard, so we can kind of swap between those two maps. So if you apply the 11.2% increase to the coastal dyno on the flywheel, that works out to 180 kilowatts on the flywheel. So to put that into perspective, 180 kilowatts is 240 horsepower on the flywheel, which is, I think, is pretty impressive for what we've done here. And it's been a real mishmash and a real Frankenstein thing. And we also only running 43mm throttle bodies, and we're limited with a regrind camshaft and all of that stuff. But overall, I'm very, very happy with the results. And I must say a massive thank you to everybody who's made this happen and assisted with this, and all the effort that's gone into make this little BM a little screamer and Mighty Mouse. So massive thank you to everybody. So 240 horsepower on the flywheel, very happy with that. 111 kilowatts on the wheels, up 1500 above sea level, is all relative because we're all racing them. Yeah, so yeah, very happy with that. That's slightly down on a stock 330 M44-B30, but we are definitely down on weight as well, so it should be fun. And what we are doing now is we're pretty much getting ready for a first test on the car. So that's how we're going to wrap this episode up. I've got a new guy working with me. His name is Given. He's over there, and he's just running through a few things. We made a massive list of things to do, and we pretty much got all of that stuff done. So I've built in some ducting for the fan. We're just putting on the front floor piece and just kind of finishing up the little bit. From here we're going to take it to the track and do that one session. I only have time for one session today. It's about a week and a half before the race that I want to run, so yeah, I'm super excited. The car ran well on the dyno, temps were fine, everything is good. It sounds glorious, so a bit nervous, but yeah, we've also got a bit of work to do before the first race, so that'll be in the next episode of the things we have to do, and that's just for heat management and stuff like that. So yep, let's just get this car to the track. Need to show them my stamp. Seating position is a bit close still. So these tires haven't been on the track for a while. pressure. Temperature is actually too low. So as you can see, the ECU cut the engine as we got into certain corners, and that's basically as I started to build speed and apply G-forces into the car, the ECU started cutting the engine, and that only meant one thing: oil surge. So we built in a protection for low oil pressure at RPM, and basically that's exactly what it did. So all the work we did on the sump essentially didn't stop the oil surge, and I'm super surprised by that, but yeah, it is what it is. So otherwise the car is good. It looks like the ECU saved the engine. There's no funny sounds, everything looks okay. I haven't drained the oil yet, but it still looks good. So I'm super happy with the engine. It's just that now we have this oil surge challenge, so I'm going to look into that a bit more and look at alternatives and solutions. If you know, on what we can do. Obviously there's the Moroso accumulator that you could use, or something similar. So there are options like that. There's a dry sump option. So I'm going to do some research and let me know what you guys think in the comments, which way we should go with that. So that is definitely the end of this build series for this engine, but it is not the end of this car and this engine. Basically, I've got some really amazing ideas of how we can take this car forward, and stuff I want to do just to improve the car. So obviously we have to work on the reliability first. If you look at the data, I was going through the data from that session. There's a lot of very encouraging signs from the performance of the car, the package. Although we never got to chase any specific laps, we still have the data shows that the car has a lot of performance and a lot of potential, and that's very, very encouraging for me. So there's I also managed to do some baffling or shrouding around the radiator, and that made a massive difference on the cooling. So there's some cool stuff I want to do there, and then there's a lot of other upgrades we're going to do. So this is definitely not the end of this this car and this engine, but it's, like I say, it's the end of this build series. So thank you everybody for watching it and supporting me. She just looks so good. If you look through there, you can see the aluminium plate I put in to basically seal up the radiator. We've still got some opportunity here in between to close up, places to close up, but already I can tell you that it was running too cool on the track when I tested it. So it didn't really go past 65. So basically I need to reinstall the thermostat. I took that out, but we need to reinstall that, and there's a lot of cool upgrades we're going to do, but she is super clean.